Good day, everyone. Today we are going to be looking at a very important question in physics, and this is a typical question from charges and Coulomb's law for electrostatics. Remember the electrostatics we did and what charges are. Today I'm going to be showing you guys the best ways to solve this problem you're seeing here and all possible shortcuts to the question. But you must give yourself wholly to the class. Don't distract yourself by any means in order to get everything clearly. Turn on your notification bell and please subscribe to this channel if you have not done so. This is the best academy. We are here to guide you. So now let's get to business. The question we are having here is that charges Q1 equal to plus 4 microcoulomb and Q2 equal to plus 9 microcoulomb are positioned on the x-axis at s equal to 0 and at s equal to 4 meters respectively. Where on the x-axis can a negative charge Q3 be placed so that the force on it is 0? I don't know. The first thing is for you to understand the question. Now, what is this question trying to say? Now, they said charges Q1 is actually equal to plus 4 microcoulomb. This you miss micro. Then Q2 is plus 9 microcoulomb as well. And they are positioned on the x-axis. You should know of x-axis is the horizontal axis. Then at s equal to 0 and at s equal to 4 respectively. That means the first one belongs to the first distance, which is s equal to 0. The second charge belongs to the second distance as equal to 4 meters. So you will draw s as which is the horizontal axis. Take your origin. Your origin is where your x intersected your y, which is somewhere I took here as my origin. Then they said at origin s and y is equal to 0. The distance from s, distance from y is 0 at origin, 0, 0. So I took this place as my origin. Then I placed my Q1 there because Q1 is located at s equal to 0. So I place my Q1 at the origin. Then Q2 is located at s equal to 4. Then I measure 4 meters to the right since the distance is positive. So you should go to the positive x. So I measure 4 meters to the right and placed my Q2 there. Then I said where on the s-axis, anywhere you like, anywhere at all is possible. They said where on the s-axis are you going to place a charge, a negative charge Q3, so that the force on it will be 0. Now you can try your best to check where you are going to place the charge, but remember that like charges will repel, while unlike charges what we attract. Now if I place the charge in somewhere here, you discover that this is a positive charge, this is also a positive charge, this is a positive charge, not negative. So you have to understand the concept of charged bodies. Like from that electrostatic law of charges, we stated before that like charges will repel, while unlike charges will what? We attract. So if you place the charge, but if you place the charged body here, this is negative charge Q3, this positive charge will be attracting it towards itself. You see where the charge will be going. So let's assume the charged body was here. It's called that this will be attracting it toward this direction. This also is positive. It will also be attracting it toward that same direction. So if both forces are moving in the same direction, their total will not be equal to 0 since they are in the same direction. Then if you place it somewhere here, because you'll be along the x-axis, Yeah, places here the same thing. This one will be attracting to itself, while this second charge with the Q1 will also be attracting to itself. Both of them will be moving to the left hand side. Both of the two forces will be moving the charged body to the left hand side. So therefore, if both forces are going to the left hand side, it will not be zero. But if you place the charged body at a point in between the two charges, between the two charged bodies, but not necessarily at the center, because we don't know where, we don't know the exact spot we're going to place the charged body, but we know it's negative, and we know that the distance between Q1 and Q2 is 4 meters. So let's play the charge here and call the distance from the origin to that charge x, because we don't know it. That's what we're looking for. Where on the x-axis are we going to place it? So let's call the distance x. So let's say from x meters from the origin, we'll place the charge there. So if from here to here is x, and from here to this other charge is 4, what will be the leftover distance? It will be the total distance minus this x. So from here to here will now be 4 minus x, which is the total, which is 4 minus this one that you have already measured, which is x. So here is x, from here to here is s, then from here to here is 4 minus x. So we have already drawn everything. So the next you are going to do now, you check. Now, if you check this very well, it's called that this Q1 will be attracting this minus Q3 towards itself. So the forces will be coming to this direction. So that means Q1 will be attracting Q3 to this side, that is towards itself, because it will be attraction means it will draw it closer to itself. So the force will be going towards this direction. That's why you see the arrowhead F1. The same thing Q2 will be also trying to attract the the Q3 towards itself. This is the force of attraction. Then that force will now be going to the right hand side. Call that one F2. So the distance between Q2 and Q3, I'll call it arrow 2. I'll call it distance arrow 2, which is from here to here. The distance between Q1 and Q3, I'll call it arrow 1, which is from here to here. So remember, Q1 is this, which is 4 microcoulomb. Micro means 10 raised to the power minus 6. That will be coulomb. Then 9 microcoulomb. This micro means 10 raised to the power minus 6. That is coulomb. Then Q3 is minus. Let's call Q3 minus Q. Q is a negative charge. And the value is not given. Let's just call it minus Q. Then let's call arrow 1. The distance between the Q1 and Q3, which is x. Arrow 2 is distance between Q2 and Q3, which is 4 minus x. So after this, let's see what we are going to have, because we are going to calculate our Q1, we are going to calculate our F1, calculate our F2. Now let's calculate both F1 and F2. Take note of this diagram, very important. I already showed you how it was drawn. So take care of it. Take note of it is very, very important. So from here, our F1 will be equal to KQ1 Q3 over arrow 1 square. F2 will be KQ2 Q3 over arrow 2 square. Then the net force, which is the total force, will now be the one going to the right, positive, then the one going to the left, negative. F2 is going traveling towards the right hand side, it's positive. That's why this one don't have any negative sign. The F1 is moving towards the left hand side, that's why it's having negative sign. So we're going to have F2 minus F1. And they said, what will be the value of that distance x such that this total force will be 0? Or how can both F1 and F2 be equal to each other or be the same thing? What will be the distance x that will make these two forces to be the same? Because it's when they are the same, the what is it called, will be equal to 0, the net force between them. So if F2 minus F1 is equal to 0, if you move F1 to this other side, it will change to plus. So we'll now have F2, then this one moves to the other side, it's equal to F1. Now what is F2? Just substitute F2 here, substitute F1 into this place. Then K, we cancel out K. This K here, we cancel out this K. Q3, we cancel out Q3. We have Q1 left here, we have Q2 left here, arrow 2, arrow 1. Then we'll be having this. So the next thing, what is Q2? Q2 is 9 exponential minus, okay, that is 9 times 10 to the power minus 6. What about F1? 4 times 10 to the power minus 6. Then what is R2? 4 minus S, then you square it. What about R1? X, then you square it. The next, this 10 to the power minus 6 and this 10 to the power minus 6, they are equal to each other, they will cancel out. So this will cancel out this. They will have this over this and this other one over this. So that's what I have here. The next, let's open this bracket. Now you can open this bracket by multiplying 4 minus S twice. You have the answer. But I have a way of opening this now that may be shorter, in which we just take 4 square minus 2 times 4 times x, then plus s square. That will be very short. That's what I did there. Just take 4 square minus the power times this first term times the second one, then plus the plus is not here. That is how to do it. It's just a short it's a little short cut. So we just be 4 raised to the power 2, then this minus, if it's plus will be plus, and this one, this time we go with it. 4 raised to the power 2 minus this 2 times this 4 times this x, then plus, that one must be, the last one must be plus this s square. That's how to do it. So that's what I did there. 4 square minus 2 times 4 times x, then plus s square. Then it's equals to 4 over s square. So that's all. So let's move to the next to see what we are going to have. Alright, we are going to have this. Then you cross multiply. This times this times this, just cross multiplication. 4 times, okay. S square times 9, we have 9s square is equals to 60 times 4, 64. Minus 8s times 4 minus 32x. Then plus s square times 4 plus s square. Then move everything to this other side and equate it to 0. If you move everything out of this place now, 0 will be left there. There's nothing there again. Move everything to this side. You're going to have this. The next, if plus 4, move to minus 4, minus 32, move. The signs will just change. All their signs will change. Both those that were positive before will change to negative. Those that were negative before will change to positive. If you divide this, you're going to have this. So automatically, this is called quadratic equation. This is a quadratic equation. So if you want to solve this quadratic equation now, you can either use your calculator, cash calculator, if you can do it, or you will use your what is it called? Your method of resolving quadratic equations, like this formula method now that I want to use. So this s will now be equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a. Now what is a? A is the coefficient of s squared, which is 5. What about b? Coefficient of x, which is 32. Then what about c? C is the constant number that don't have edge, which is minus 64. That's minus 64. So since everything to this formula, we are going to have this. Then if you simplify this bracket, that is this square root, that is 2 square, you are going to have this. Then minus times plus. Okay, minus times minus will give us plus. That's why this one is not plus. Was not plus. Then everything here multiplying each other will give us 6. Then 2 times 5 will give us 10. That's what we are going to have. If you solve this, you're going to have this minus 32 plus or minus root of 2 304 over 10. And the square root of 2304 over 10, square root of 2304 is 48. So if you find the square root, we're going to have this. Then we have minus 32 plus or minus 48 over 10. Then if you want to get the final answer from this place, now if you ever see minus 32 plus 48 over 10, or minus 32 minus 48 over 10. That's what we're going to have. That's what we have here. If I do the plus, we'll have to sign plus or minus. So I'll do plus, then you do minus again. Then next, minus 2 plus 48, we have 16, that's over 10. Minus 32 minus 48, we have minus 80 over 10. So this divided by 10, we're going to have 1.6. So S is either equal to 1.6 meters or then minus 8 meters. But remember the question we're solving. The distance we're taking was to the positive s, so the positive answer should be the correct answer. The most correct answer here should be this positive one, which is 1.6 meters. So this is the normal solving. Then if you wish to also solve it maybe with your calculator from this quadratic equation, if you want to solve it with your calculator, then you are going to do it like this. You're going to click your mode, click mode, then you click 5, which is equation. So you click 5, click on 5, because 5 is showing equation. So you click on 5. Then you look for the equation that is like a quadratic equation, which is this number 3. So you click on 3. So remember, the first thing you do, you click mode 5T. That's the first thing, mode 5-3. Then the next thing you do, you are going to impute the question into the calculator. Now our A is what, and B is what, and C is what. I already showed you A, B, C, D. So from this question now, from our question we have here, our A is 5, B is 32, then C is minus 64. So for A, you press 5, since A is 5, then you press equal to, for it to enter into the calculator, you press equal to, then B is 32, that's 32, you press 32, then you press equal to, then C is minus 64, so you click on minus 64, then it's better use this small minus, this is between numbers, minus 64, then also click equal to, so you can see we have 5, 32 minus 64. Then what will be the answer? If I press equal to the first time, they're having 8/5 as fraction. Then to check the decimal equivalent of this, you click this button here, which is S/D. You click this to get the decimal equivalent of that, which is 1.6. To add 1.6 before, we were solving using quadratic formula. Then to get the second answer, press equal to again, you have minus 8. So this is how you solve the quadratic equation with your calculator. So I hope it's very okay. So that is will be our S2. So remember the procedure: mode 5, then you press 3, then impute your A, impute your B, impute your C accordingly. Remember, your A is the coefficient of S squared, your B is the coefficient of S, while C is the constant number there, or the coefficient of the unknown square is A. The coefficient of the unknown that has a power as 1 is B, then the constant number is C. That's how it is done. And if you wish to solve it from here directly with your calculator, that's from this place. If you wish to solve it from this place directly with your calculator, or from this place, or even from here with your calculator, is also possible. It's also possible. So I'll be showing you how to do that now. Now you are going to do it this way. So what you are going to do, you are just going to impute the question into the calculator as follows. Look at it. This is a little trick that you have to know. Remember, we have KQ1, Q2 over R square, and we're not saying F1 is equals to F2. F1 is equals to F2. What is F1? So we already solved it and we got K cancel out K. Then Q3 cancel out Q3. We now have a Q1 over R square. That's Q2 over R square, R2 square, equal to Q1 over R2 square. I don't know if you can see, get that. It's there. So if you want to solve directly from there, you're going to have something like this. You have it this way. Press. Since you have fraction, if you have fraction, this is symbol, this is button used for fraction. This button here. So you click on this button. So this is the, so The first one was 9 exponential minus 6, that's 9 microcoulomb. So that's for Q2. So you press 9 exponential. Look at exponential here. Exponential minus 6. Then you go to the downside with your replay button. Then you click on this bracket. 4 minus x. 4 is 4 again. 4 minus x. Now, how do we impute s into our calculator? How are we going to do that? So let's try and see if we can do that. So type 8 into your calculator. You're going to press alpha. You press alpha, then you press this close bracket. That'll give you x. It's a very simple thing. Then you close the bracket, then square it. Then you press the forward part of your replay button, the forward part. Then the result come to this place. Then how do you press equal to? Press alpha, then press calc. So give you equal to. Then second one is 4, that is Q1 over R square. So it's still a fraction, so you have to click on this button. And Q1 is 4 times 4 exponential minus 4 minus 6 exponential minus 6, then over s square. So press this whole part. So how do you press s? Alpha bracket alpha close bracket. I'll give us s, then square. So you see, this is the question we're having before. So it's already inside our calculator. So that's first you try and type it inside the calculator. Just impute the question accordingly. Then the next you do to get the final answer now, you press shift calc. Now we will solve for x. This is not the answer yet too. Then you press equal to get the value of x. Press equal to. And you wait. The calculator will display the answer. Alright, this is the only issue here, in the sense that the answer you're going to get from this calculator directly, when you set the equation directly, without converting it to normal quadratic equation first, then use quadratic procedure. Instead of you to have two answers, you will display only one of the answers. That's the issue. So you can see it's displaying the minus 8. Minus 8, not the 1.6. Remember we had minus 8 or 1.6. So that is